want to talk a little bit about horizontal asymptotes for rational functions. And I'm going to start with the parent function of rational functions. It's 1 over x. So a horizontal asymptote is what happens as x approaches infinity and as x approaches negative infinity. In other words, as our x's are getting larger, what's our graph going to look like? And as our x's are getting smaller, what's our graph going to look like? So with this particular rational function, it's pretty clear to see what's going to happen. Because if I'm looking at 1 over x, and as x starts to get really, 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 really large, well, my y value begins to approach 0. It gets really, 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 really small. But no matter how small it gets, it can never really approach 0 because I still always have this 1 over something really, really large. And similarly, as x gets really, really small, starts going towards negative infinity, my y value is negative, but it's a smaller and smaller negative. It's getting really, 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 really negative. So my horizontal asymptote, the line that is guiding the behavior of my graph as x gets really large and as x gets really small, is the x-axis, which is y equals 0. It approaches the x-axis, but it never quite touches it. Now, if I have a constant, so I have f of x equals, let's say, 5 over x. Does the 5 really make much difference? I mean, we know that the 5 is an a, so it's really 5 times 1 over x. We know that our parent function is going to have the horizontal asymptote at 0 because as x gets really large, y is going to approach 0. But does it make much difference multiplying it by 5? If x is equal to a gazillion, however many zeros a gazillion is, does it make much difference if it's 5 over a gazillion or 1 over a gazillion? No, it doesn't really make any difference. Our horizontal asymptote is still going to be approaching that 0. As x approaches infinity, our horizontal asymptote is still going to be approaching 0. So really what I'm saying here is that any time we have a constant over x in our function, our horizontal asymptote is going to be y equals 0. It's going to be the x-axis. Anytime we have a constant over a variable, our horizontal asymptote is going to be y equals 0.